investigating how the volume of acids and alkalis affect their pH. So we'll begin by using 1 milliliter or 1 centimeter cubed of hydrochloric acid. Now, I'll be using a pipette to take it out of its container and then measuring it in a measuring cylinder. Now, I have 1 centimeter cubed of the acid, which I will put into my test tube. I will add the universal indicator to my acid. We can see that the acid turned red. This means it has a pH of around 0 or 1. Now I'm going to add another centimeter cubed of the acid to this test tube. Always remember to use your measuring cylinder to measure the volume of any liquid or aqueous solution. So I've now added 2 milliliters or 2 centimeter cubed in total. And as we can see, the color of the acid has not changed. It is still the same shade of red, having a pH around 0. Once again, I'll measure another centimeter cubed of the acid using my measuring cylinder. I will add it to my test tube, and the color does not change. This is because the amount of acid particles in each centimeter cubed of the liquid does not change. So although the volume is increasing, the pH of the entire solution remains the same. Now I will try the same thing with an alkali. So using a clean measuring cylinder and a clean pipette, I will measure 1 centimeter cubed of sodium hydroxide. I'll pour the 1 centimeter cubed sodium hydroxide into a clean test tube and add a universal indicator. We can see that it has turned a dark purple, indicating a pH of around 13. I will now add another centimeter cubed of alkali, this alkali is sodium hydroxide, to my test tube. You can see the color has not changed. It is still the same shade as purple, still having a pH of 13. Once again, I will add 1 more centimeter cubed of sodium hydroxide to my measuring cylinder, as we always have to measure volume using a measuring cylinder. And then I'll pour the sodium hydroxide into my test tube. Once again, the color remains the same. So when we add more volume of the same alkali, it does not change the pH.